With all of these in number 8, you want to isolate the trig function and then think about what input is going to make the equation true. So in this case, we're going to isolate cosine x by adding 1/2 to each side. We go to our circle and think, where is cosine positive? It's positive in these two quadrants, and we need it to be positive 1/2. All right, 1/2, when we think about our three ratios we work with most, is the smallest value. So remember, a bigger angle is going to produce a smaller x value. Here's our x value. Or a smaller angle is going to produce, or sorry, this produces a smaller x value. A bigger angle produces a larger x value, right? So we want to work with, or a smaller angle, I keep mixing up a smaller angle produces a larger x value. A bigger angle produces a smaller x value. So we want a bigger angle to get our 1/2. So when we think about the three angles we work with most, 30, 45, 60, well, we want 60, which is pi over 3. So x is pi over 3. And then what's the reference angle in the fourth quadrant? This is 6 pi over 3, so down here is 5 pi over 3. So we have pi over 3, and oh my gosh, how did that come out looking like an 8? 5 pi over 3. Hopefully I get back on track the rest of this video. We'll see. Okay, so we want to isolate -8, or we want to isolate sine x, so we subtract root 3 from both sides. We get -8 sine x. 5 root 3 minus root 3 is just equal to 4 root 3. Divide by -8 on both sides. Okay, we get sine x equals 4 over -8 is going to simplify to 1 over -2. So this is negative root 3 over 2. Whereas sine negative, it's negative in the bottom two quadrants. All right, negative root 3 over 2 is the bigger of the ratios that we work with. And remember, bigger angle produces bigger y value. So we want our pi over 3 60-degree angle again. So if this is 3 pi over 3, down here would be 4 pi over 3. If this is 6 pi over 3, down here would be 5 pi over 3. So x is 4 pi over 3 and 5 pi over 3. Next, sorry, look at that for a second. Okay, next we're going to multiply by 2, get 4 sine squared x minus 5 equals -4. Add 4 to both sides, or add 5 to both sides, we get 1. -4 plus 5 is 1. Sine squared x equals 1/4. Sine of x equals plus or minus the square root of 1/4, which is going to be plus or minus 1/2. So the thing with these problems is you must get down to one of the ratios that we can find off of our unit circle knowledge. If it's not one of those nice ratios, then something must have gone wrong. Now the nice thing about these square root ones is we end up with our plus or minus, which means we have answers in all 4 quadrants. So once we figure out that our reference angle is pi over 6, we need to figure out what our pi over 6 reference angle is in all of the other quadrants. So this is 6 pi over 6. So up here we have 5 pi over 6. Down here we have 7 pi over 6. 5 pi over 6, 7 pi over 6. And then if this were 12 pi over 6, down here would be 11 pi over 6. So 11 pi over 6. There's our 4 answers. Last one. We divide by 3 on both sides. We get secant x equals 2 root 3 over 3. Now this one's a little tricky. You might be able to figure it out from here, but I think what I want to do is say, let's make this cosine x. And if we make it cosine x, we can just flip our fraction. So then we get 3 over 2 root 3. And then, like I said, we need to get down to one of those nice ratios or else there's a problem. So let's just keep messing with this. Maybe we multiply by root 3 over root 3 to rewrite it in a different way. So we get 3 root 3 over 2 times 3, because our square roots cancel there. And then, our 3's cancel, and what do we get? It's root 3 over 2. So really we're looking for where cosine x is equal to root 3 over 2, which is going to be in these two quadrants. It's going to be a smaller angle to produce a bigger x value, so that's our pi over 6. So x is pi over 6 and 11 pi over 6.